This is part 2 or week 2 of the aluminum lab. If you notice, you're seeing the white crystals of the potassium aluminum sulfate dodecahydrate. Now, because we left it too long, all the water evaporated off. So all we have is the white crystals. And if you were to look into the beaker, you would see them. Very nice crystals. Now what we need to do is take those crystals, rinse them off with a little bit of alcohol, run them through a filter, and then dry them a bit and weigh them. So I'm going to loosen the crystals with a spatula. Okay, so you can sort of see the crystals. And they're sort of damp. You can see that they're damp. And what we're going to do is rinse them with alcohol, ethyl alcohol, drinking alcohol, or ethanol. Okay, this is the last part of the experiment. We have to wash our crystals. We're going to use a sidearm flask. If you notice, this is a sidearm flask. It's got a little arm on the side here. We'll hook it to a vacuum line. And then I will put a filter back on top, a Buchner funnel. This is a Buchner funnel, if you're not familiar with it. And then I'll put filter paper that's pre-cut that fits exactly in there. And when I turn my vacuum line on, if you notice, to get a good seal, you can see that I got a good seal. Okay, so I want to rinse my crystals, so I'm going to rinse them with a little bit of ethyl alcohol, because there's a little bit of water in there and I want that water out. So I'm going to just run them through the crystal filter, and if you notice, the alcohol is coming through, but not the crystals. Now I'll let this run a few minutes, and as it pulls the air through, any water that's in the crystals will be pulled out by the alcohol. And so I'll let this run to dry, and this will take a few minutes. And you can see the dropping is getting less and less. And I'll let that run for a few minutes. Then we will take our crystals and weigh them. Okay, I believe my crystals are dry enough to weigh, so I'm going to take an evaporating dish, or not watch glass, excuse me, a watch glass, auto zero it, put my crystals on there, and then just weigh just my crystals. So I'll take this off. So what I did is I took my crystals out of the Buchner funnel, put them on my watch glass and weighed them, and I had 39.709 grams of crystals. So that's my experimental yield. I'm not sure if they're absolutely dry or not, but we'll go through with the calculations so you can follow along. So that's how many grams of potassium aluminum sulfate dodecahydrate obtained from my experiment. Now I need to calculate the theoretical. To do that, if you go back to the original equations, there are 3 reactions taking place. You started out with aluminum, you produced potassium aluminum hydroxide, you took that potassium aluminum hydroxide, reacted it with sulfuric acid, produced potassium aluminum sulfate. Then you took that potassium aluminum sulfate and allowed it to create the hydrate, potassium aluminum sulfate dodecahydrate. So we have to go through the stoichiometry from here to here. Now if you notice, this is 2 to 2, or really it's 1 to 1. This is 1 to 1, and this is 1 to 1. So you're very fortunate in that the stoichiometry is all 1 to 1. And so if you chose to ignore it, you'd still get the right answer, but for the wrong reasons. Okay. So what I did, I started out with my sample of aluminum, 1.505 grams of aluminum. I know there are 27 grams of aluminum in 1 mole of aluminum. I know that 1 mole of aluminum produces 1 mole of potassium aluminum hydroxide. 1 mole of potassium aluminum hydroxide produces 1 mole of potassium aluminum sulfate. 1 mole of potassium aluminum sulfate will produce 1 mole of potassium aluminum sulfate dodecahydrate, and 1 mole of potassium aluminum sulfate dodecahydrate should have a molar mass of 474 grams. I just added up the atomic mass of that. So going through and doing the calculations, theoretically I should have gotten 26.42 grams of product, assuming 100% yield. Now notice, theoretically I should have gotten 26.42 grams. Experimentally, notice I've got way more. I've got 39 something. So I've got a huge experimental error. So my experimental is 39.709. My theoretical was 26.42 times 100. So I definitely know I'm going to have a over 100% yield. So I have 148% yield, which really means my crystals are very, very wet. They're not dry yet. So to dry them, I'd probably have to let them sit a week at room conditions, and then I would get a smaller answer, a smaller percentage error. So these are very wet crystals based on what this is telling me. And I would expect that because you just don't have the time to let them air dry unless you want to spend 3 weeks doing this experiment. So that is the aluminum lab, and we will give you data to calculate, and hopefully your data is better than mine.
Okay.